Well, hello everyone. This is KP, the Math G, and we are talking about this one, a 2006 free response question 4. I have done a previous video, I don't know, out of the 107th and now 108th video, somewhere in between there, I have a video on this very thing here, and of course, it doesn't hurt to jog memory. I know for me, I need to have my memory jogged more frequently than I'd like to admit. Just ask my wife. Okay, she'll tell you. All right, we're talking about, whoa, this, by the way, is T in seconds. This is B at T in feet per second. Almost forgot. Alright, so that is what we're going to do. I don't know if we'll have time to do all three parts of this, but this should be fairly familiar to you by now, but let's go over it. It says find the average acceleration over the interval t being between 0 and 80, including 0 and 80. Okay, so let's do that. Alright, it's average. Alright, so average acceleration. I know the answer is going to be in acceleration. Okay, it does say acceleration, doesn't it? Yep, it sure does. Okay. Alright, so average acceleration is going to be v at 80. Alright, average acceleration is equal to v at 80 minus v at 0 over 80 minus 0. That's it. That's it. Just, here's your t. This is your time on the bottom. V at t. That's what that is. That's just like the slope formula. y2 minus y1 over x2 minus x1. That's what average is. If they said do it over a period of between 20 and 70, you would have done v at 70 over v at 20 over 70 minus 20. That's what you would do. That's how it's done. Alright, well, I know what v at 80 is, don't you? It's 49. Alright, v at 0 is 5. Alright, 80 minus 0 is 80. 44 over 80, which is, I want to say, 11 over 20. They want the units, so we are going to give it to them. Well, when I see in the problem average acceleration, alright, then this is going to be acceleration. That's feet per second squared. And that's it. 1 point for setting this up, 1 point for the answer. Later on you get a point for the units, okay, throughout the entire questioning, and that's it for the A part. Average, always v at B minus v at A over B minus A. That's it, average. Immediately know to do that. Okay, there it is. Alright, second question. We're just going to move along because the third one may take a little time, and I don't know if I'll have time to work on the third one, but we're going to go ahead and do that. Okay, let me see something that make sure that everything is lined up here on my camera. Yes, it is. Okay. I usually move my board over a little bit, but I'm going to leave it here now that I've got it here. I knew I was running out of room over here for some reason. Alright, so let's go ahead and do the B part. Well, alright. Alright, now they would ask probably one of four questions. In this particular case, I'm going to try to abbreviate here. They are asking for the meaning. I'm going to abbreviate of the interval 10 to 70 b at t dt. Alright. In terms of a rocket's flight. Okay, so we are talking about a rocket here and rocket's flight. Alright. Also keep in mind that we're doing the midpoint. We're doing the midpoint approximation. Alright, I'm just going to abbreviate there. Now, we have to do three, what does it say? 3 subintervals. Okay, so 3 subintervals. Okay, I'm going to try to be brief with this, but we're starting from 10. Alright, start at 10, skip 1. If we're going to go 3, here's 1. Alright, 1 subinterval. The second one is from here. Okay, that's the second one. And then the third one would be here. And that's equal subintervals. Alright, they're of equal length. How far is it? 30 minus 10 is 20. Alright, 50 minus 30 is 20. 70 minus 50 is 20, so they're even. Alright, so we know that delta x is 20. Alright, and then what we do is, since we're doing that, we're taking the midpoint between 10 and 30, and that's 20, and we're just looking at the y value. B at t is 22 plus the next one between 30 and 50 is 40, so we're looking at the y value. B at t is 35. Okay, I say y value, the velocity in terms of feet per second. And then again, the third one, 60 is between 50 and 70, we're looking at 44. Okay. If we add all that up and multiply, we're going to get 20 feet. Alright. Let me say this. Usually they may ask for, instead of 3 subintervals, they may say 6 subintervals. If they had to ask you for a left approximation, then you would do it this way. And I'm gonna do very quickly. I know they didn't ask for that, but I'm gonna go over very quickly what that would look like. This is it right here. The midpoint is here. A left approximation. I call it left hand approximation. That's going to be 10. Alright, so in other words, you would go from 10 to 20, 30, 40, 50, 60, 70. That would be 1, 2, 3, 4, 5, and 6. There's your 6 subintervals that we're talking about, but it would be in groups of 10. So you would count the leftmost, 14. Also these, all but the last one. Okay, 1, 2, 3, 4, 5, 6. So you would do 14 plus 22 plus 29 plus 35 plus 40 plus 44. Alright, and I did that right on my scratch paper here, and I got an answer of 1840. Alright. And oh, by the way, this is in feet because when you integrate velocity, you get distance. Alright, how far did the rocket travel? Alright, 2,220 feet. Alright, and that's what we're talking about here. Alright, this is 1840 feet. Alright, if you want to go ahead and put that unit there, that's what you do. If you're doing a right-hand approximation, I'm just going to erase this. You would leave off the 14, and you would start simply at 22. So in this case, you would leave off the 14, and you would go all the way. You would include the 47 on the end. So in this case, that would be, instead of ending at 44, we end at 47. And one way that I've said to memorize that, if it's a right one, start at 70 and then 40, count back until you get to right there, 1 away from 10. If you're doing the left side, start from 10 and count 1 away from 70, and there you go, one more. Don't go all the way over, okay? And then now you still have 10, because that's delta x is still 10, 10, 20, 30, 40, 50, 60, 70, and so on. Alright, and then the right approximation was, let's see, 2170. Alright, 2170, like that. So that would be a right-hand rule right there, okay, or approximation, which you're not doing, okay, but if they ask for that, that's what you would do, okay. Let's say they said trapezoidal, you still would do 10, okay, like this, and probably six sub intervals, okay, instead of 3 like we've been in it. But you would just do, you would still, okay, okay, let's see, I think what you would do there is 10 times 14 plus 2 times 22 plus 2 times 29, right, plus 2 times 35 plus 2 times 40 plus 2 times 44, 2 times 44 plus 47, okay, 47, like that. So on the first one, you don't multiply by 2, and on the last one, you don't multiply by 2, but when you get through, actually you divide by 2, so actually that's 5 instead of 10, okay, you can do it that way. And actually what you can do is, if you knew the left approximation was 1840 and you knew the right approximation was 2170, then you could add these up. Okay, add them up. 4 7's 11, 8 and 1's 9 and 1's 10. Alright, and 40 10 I want to say, and then divide that by 2. Alright, so 40 10, 40 10. Alright, divided by 2. Alright, like we did here, we're dividing everything by 2. That's going to be 2005, 2005. Alright, like that. That's just the average of the left and the right. So what that is, that's what trapezoidal is anyway. But if you had to just set it up, that's the way you would set it up. So I just wanted to show you every possible question they could ask you. If they would do a left or a right or a trapezoidal, likely you would have 6 subintervals, but we had to do midpoint, so all you had to concern yourself with was 3, and that's because you had to do, the midpoint is done differently than the other 3 methods, okay? The other 3 approximations. Alright, well, that is a crash course on all 3 of them. That's what I was wanting to show you. And you would have 3 approximations there. Well, I'll write it down, but anyway, that's it right there on that one. Okay, so much for that. And that was just a real quick review. That's what I wanted to do on this one. Let's see if we can do the C part. Okay, I don't know if we're going to have time. Now, this is, by the way, this is, oops, I want to say this is rocket A. Alright, so this one's going to be rocket A. Alright, given by this table right here. Okay. Alright, rocket B. I was hoping I could just do a little crash course on that and kind of help you see what you need to do if they were asked for something else other than the midpoint. Riemann sum. Alright, part C is rocket B. It's given by A at T is going to be 3 over the square root of T plus 1, and that's going to be feet per second, which is feet per second, well, second squared, okay, like that. It's really, that's what that is. At time T, I don't know if I'll run out of time if my camera runs out on me. Well, I'll do C again, okay, the C part again. So if I run out of time, I'm sorry, but I'm going to try to get it in. Okay, at time T equals 0, the height is equal to 0, and the initial velocity, alright, so B at 0 is 2. Alright, feet per second. Alright, feet per second. Okay. Which rocket is traveling faster at time? So faster. We're looking at the faster one at time T equals 80 seconds. I think that's, yeah. Alright, explain your answer. Okay, remember we're looking at faster, so that's rate. That's going to be the velocity, feet per second. Acceleration is not the same as saying how fast. Okay, you know, it's actually the rate of the speed is what that is, but we want the speed, or actually velocity itself, okay, which is in feet per second. So that means that we have to integrate this problem here. Okay, so in other words, we have 3, and I want to say this is actually 3 over T plus 1 to the 1/2 dt. Alright, I want to bring this up here, okay, like this. I don't like this, well, it's just difficult to do. I'm going to do this by hand. Alright, so what I have is 3 over, no, I'm sorry, my bad, it is 3 times T plus 1. If you bring this up, this will be to the negative 1/2 dt. Alright, so in other words, 1 over A to the n is equal to A to the negative n, and that's what I did. I brought it up and made it negative right there. now, I mean, I could let u be t plus 1, alright, but du is equal to dt, so there's no real point in that. So this is actually going to be equal to 3. Alright, this is, remember now, this is, if you say it's u to the negative 1/2. Remember, when you add 1 to that, that's going to be 2 halves. 2 halves, negative 1/2 plus 2 halves is 1/2, right? So u to the 1/2 over 1/2, which is the same as u to the 1/2 times 2. Alright, so 2. So times 2. U is t plus 1, so t plus 1. Now remember, this is a positive 1/2 right here, to the 1/2 plus c. Alright, so let's see, now we've just found v at t in relation to rocket B. Alright, so alright. So do you understand that I had to raise this up? And I guess maybe I should have gone through everything on this one. Okay, so u is equal to t plus 1, du is dt. And then, of course, I just did this a while ago with u to the negative 1/2. Alright, and then that's going to be, that is u. So if you needed to see that, I'm sorry I didn't put that up sooner, but I try to visualize it, and sometimes we can't all visualize like this. This is 6 now. Alright, so this is equal to 6. So now v at t, this is rocket B. Alright, rocket B right there, is 6 times t plus 1 to the 1/2 plus c. But now we need to figure out what c is. Now I do know that v at 0 is equal to 2. Alright, so 2 is in place of v at t, and 0 is always in place of t itself. So right here I'm just going to plug the 0 in, and there it is. This, by the way, is the square root. Alright, so 1/2. Let me just go ahead and rewrite it here. Alright, so up here is going to be 2 is equal to 6 times the square root of 0 plus 1, which is 1, plus c. Alright, so 6 times 1 is 6. So 2 is equal to 6 plus c. So subtract 6 on both sides, and we have negative 4 is c. Alright, so negative 4 is equal to c. Alright, I know I need to hurry. Alright, so in this case, the c is negative 4. Negative 4 right there. And this 1/2 is the square root. So 6, 3 times 2 is 6, times the square root of t plus 1 minus 4. Alright, there it is. And then now I need to determine if it's faster when at t equals 80. Alright, so that's what I'm looking at. So v at, so this is what I'm looking for. Alright, so v at 80, alright, is equal to 6 times the square root of 80 minus 4. The square root of 80 is 80 plus 1, I'm sorry. 80 t plus 1 now minus 4. I knew something didn't look right. Alright, this is the square root of 81, now minus 4. 81, square root of 81 is 9. So 6 times 9, 6 nines are 54. 54 minus 4 is 50. Alright, so in other words, VB at T, 80, let's just say 80, is equal to 50, and that's greater than the, what am I doing that for? VA, actually rocket A of 80, which is equal to 49. Alright, not by much, and our units are in feet per second. Feet per second. Alright, there we go. Whew, I did that relatively fast, and I'm sorry, usually I just want to do one thing and go at it at that one at a slower pace. I started to do just part C first, but I figured I could get the other two parts in fairly quickly. Alright, so anyway, I hope this has helped you. This is KP the Math G. Please subscribe. I'm getting more and more subscribers. I appreciate that. If you haven't subscribed, please do so. I want to encourage you to subscribe if you haven't already. And also, please make a comment if you feel free to make a comment if you'd like to, and press that like button. That just puts a smile on KP the Math G's face here. Alright, anyway, I appreciate all of you. I appreciate your patience with me. I know I just have this plain board, but this board is really, I love it. I love doing that. I don't have all the technology that some of the other people might have, but I can still give you what I've got up here. Alright, and that's what I have worked to get where I'm at now. I did not get this overnight, and I've had to really work at it, and it's not to my glory, but it's to your glory. Alright, KP the Math G signing off. Have a great day.